We are one step closer to answering the age-old question, are we alone in the universe?
NASA has hit the jackpot this time. Okay, the Holy Grail is to find an Earth-like twin in outer space.
We're one step closer to answering the age-old question, are we really alone out here? NASA's just made a mind-blowing discovery with the James Webb Space Telescope, and it's pretty crazy. They've captured the clearest image yet of Proxima B, an exoplanet that's looking like Earth's twin. We're talking in perfect conditions and just the right distance. Could this be a new home for us someday? And, more importantly, could there be life out there? Let's dive in and see what this means. Life outside Earth. Proxima B is located in the Proxima Centauri system, which is the closest star system to our own. In cosmic terms, it's practically our next-door neighbor, only 4.24 light-years away. That might sound close, but in reality, even with our current technology, it'd still take us tens of thousands of years to get there. Yeah, space is big. But what makes Proxima B so special? Well, this planet has some seriously promising features. It orbits within the habitable zone of its star, meaning temperatures could be just right for liquid water. And where there's water, there could be life. Before we get too excited about booking one-way tickets to Proxima B, there's a bit of a catch. NASA's data suggests there might already be someone or something there. All this excitement around Proxima B shows just how far we've come in our search for life beyond Earth. Sure, getting there is still a massive challenge, but with technology advancing at lightning speed, who knows what the next few decades will bring? Maybe one day we'll actually set foot on Proxima B, or even say hello to some extraterrestrial neighbors. Proxima Centauri is a red dwarf. It's smaller and cooler than our sun, but don't let that fool you. Red dwarfs are actually pretty common and can live for billions of years, far longer than our sun. Even though they're not as bright or flashy, these stars are a major part of the galaxy, making up about 70% of all the stars out there. But the real hype isn't about the star itself. It's all about Proxima B, the planet that orbits it. When Proxima B was discovered in 2016, the excitement was huge. This wasn't just any random planet way out in space. It's a rocky planet, meaning it has a solid surface like Earth, which is pretty rare for exoplanets. The fact that it's rocky makes it seem like it could be more similar to our home than most of the planets we know. What makes Proxima B even more interesting is that it's about 1.2 times the mass of Earth, so it's a little bigger, but not by much. Scientists have a special term for these kinds of planets: super-Earths. It's not a super-Earth in the sense of being a massive gas giant, but it's more substantial than our planet, which opens up a lot of possibilities for exploration. Proxima B is located in its star's habitable zone, the so-called Goldilocks zone. That's the region around a star where temperatures are just right for liquid water to exist. Not too hot, not too cold. And as we all know, liquid water is considered one of the key ingredients for life. So the idea that Proxima B could have water means it could possibly harbor life. Red dwarfs like this one are really interesting because they live so much longer than stars like our sun. While our sun will eventually burn out in a few billion years, red dwarfs can burn for tens to even hundreds of billions of years, which means there's plenty of time for life to develop on any planets orbiting them. More time equals more chances for life to form and evolve, which is exciting when you think about the possibilities out there in the universe. However, there's a big catch, and it's a pretty significant one. An active star, Proxima Centauri, is what scientists call an active star. This means it's constantly throwing out solar flares, massive bursts of radiation. We're not talking about small, harmless flares. These can release enough energy to strip away the atmosphere of any nearby planets. If that happens to a planet, it could become uninhabitable, with its surface exposed to dangerous radiation. This would make living on such a planet pretty risky, to say the least. If we were to land on Proxima B, we could be zapped by deadly radiation at any given moment, which is far from ideal when you're trying to figure out how to live and thrive on another world. If Proxima B has a thick atmosphere, it could protect the surface from these solar flares. This thick atmosphere would act as a shield, preventing harmful radiation from reaching the planet's surface. It's a big if, though. We don't know for sure whether Proxima B has such an atmosphere, but scientists remain optimistic that it might. They're holding on to the idea that with the right conditions, life could still find a way to survive, even with the star's unpredictable bursts of energy. There's another issue with Proxima B, though. The planet is tidally locked to its star, which means one side of the planet always faces Proxima Centauri, while the other side is stuck in eternal darkness. So on one side, you'd have a blazing hot, sun-drenched landscape, while the other side would be a cold, frozen wasteland. This is a pretty harsh setup for any potential life to survive, as it creates extreme temperature differences between the two sides of the planet. The sweet spot, however, could be the narrow region where the day side meets the night side. This area, called the Terminator line, is where the sunlight and darkness meet, and in theory, it could have the perfect conditions for liquid water to exist. It's not too hot or too cold, and that could create a zone where life could potentially thrive. Despite these challenges, scientists aren't giving up on exploring Proxima B anytime soon. Breakthrough Starshot. This is one of the most exciting projects currently in the works, and it's trying to tackle the massive distance to Proxima B in a whole new way. The idea is to send tiny, lightweight spacecraft to the Proxima Centauri system, using lasers to push them at a fraction of the speed of light. These little probes would be small, about the size of a postage stamp, but they would be packed with cutting-edge technology that could help us learn a ton about Proxima B once they get there. If everything goes according to plan, these probes could reach Proxima B in just a few decades. That's a huge improvement over the tens of thousands of years it would take with our current spacecraft. Once the probes arrive, they would start sending back all kinds of data, from details about the planet's atmosphere to information about its surface conditions. One of the key things scientists are dying to know is whether Proxima B has an atmosphere at all. This is super important because an atmosphere could help protect the planet from those nasty solar flares that Proxima Centauri constantly throws out. Without an atmosphere, life as we know it would pretty much be impossible, since the radiation would strip away any potential for a habitable environment. If the probes confirm that Proxima B does have an atmosphere, that could be a huge step toward understanding whether the planet is truly capable of supporting life. But even before that, just getting to Proxima B would be an incredible achievement. If Breakthrough Starshot and similar projects succeed, it could change everything we know about space exploration. Instead of waiting thousands of years to get there, we could be looking at exploring new worlds within our lifetime. But what makes Proxima B stand out from the rest of the planets we've discovered? Why is Proxima B so special? This is where missions like the James Webb Space Telescope become super important. They're designed to help answer big, crucial questions about space, especially when it comes to planets like Proxima B. The thing is, Proxima B isn't the only planet orbiting Proxima Centauri. Recently, scientists discovered evidence of another planet in the system, called Proxima C. While we don't know a whole lot about it yet, the discovery is pretty exciting because it suggests that the Proxima Centauri system might be more like a mini-solar system. We could be looking at multiple planets, each with its own unique characteristics, and who knows? Some of them could have the right conditions for life too. But what really sets Proxima B apart and makes it so special to us? Well, it's all about the fact that Proxima B is really close, it's rocky, and it sits right in the habitable zone of its star. This is what scientists dream of when they think about finding planets that could support life. It's like hitting the jackpot. It's not too hot, not too cold, just the right conditions for liquid water to exist. Water is pretty much the holy grail when it comes to finding life beyond Earth, and Proxima B checks that box. Plus, it's a rocky planet, which is another sign that it could have solid ground and be a bit more like Earth. Sure, Proxima B does come with its challenges, like the constant solar flares from Proxima Centauri, and the fact that the planet is tidally locked, which means one side is always facing the star, while the other is in eternal darkness. But even with those issues, the potential is just too big to ignore. If we could overcome these hurdles, Proxima B might actually be one of the best candidates for finding life, or even living there ourselves one day. The James Webb Space Telescope has been a game-changer for space exploration, and its findings about Proxima B have been nothing short of jaw-dropping. But before we get into the shocking discovery, let's take a step back and talk about how NASA was even able to study a planet so far away in the first place. The James Webb Telescope. The James Webb Space Telescope is a huge leap forward in how we observe the universe. It's not just a telescope, it's a groundbreaking tool that allows us to see farther, clearer, and deeper into space than ever before. The idea for the telescope actually began back in 1989, when NASA and the Space Telescope Science Institute were looking ahead to what could come after the Hubble Space Telescope. They wanted to develop something that could see in infrared, which is perfect for studying distant objects in space that are hidden by clouds of dust. This marked the beginning of a project that would take decades to come to life. By the mid-1990s, the project was officially proposed under the name Next Generation Space Telescope, but by 2002, it was renamed to honor James E. Webb, NASA's administrator during the Apollo program. The telescope's design was a huge international effort, with significant contributions from NASA, the European Space Agency, and the Canadian Space Agency. Building such an advanced telescope took time, and construction officially began in 2004. Over the years, there were major milestones, such as the completion of the 18-segment primary mirror in 2011 and the delivery of all 4 scientific instruments by 2015. However, the project did face some delays and redesigns along the way, pushing the total cost to about $10 billion. Finally, on December 25, 2021, the James Webb Telescope was launched into space aboard an Ariane 5 rocket from French Guiana. The trip to its operational orbit, about 1.5 million kilometers away at the L2 Lagrange point, took around a month. After that, the telescope entered its commissioning phase, which lasted about 6 months. During this time, scientists and engineers tested and calibrated all the systems. In July 2022, they revealed the first full-color images from the telescope, showing off its ability to capture incredibly detailed images of distant galaxies, star-forming regions, and even exoplanets. The main mission of the telescope is to explore some key areas in astrophysics. It aims to study the formation of the universe's earliest galaxies, delve into how stars and planetary systems are born inside dusty cosmic clouds, and analyze the atmospheres of exoplanets to look for signs of habitability. The telescope itself is built to be bigger and more powerful than anything we've had before. Its primary mirror is made up of 18 hexagonal segments that can collect more light than previous telescopes, and its sun shield, which is about the size of a tennis court, helps protect its sensitive instruments from the heat of the sun. Unlike Hubble, which observes primarily invisible light, the James Webb Telescope is designed for infrared observations. What makes it so special is that it sees the universe in infrared light, which allows it to detect things our eyes can't see, like heat signatures or objects hidden behind clouds of gas and dust. This makes it perfect for studying planets like Proxima B, a world that's been on scientists' radar for years, but has always been a challenge to observe from such a vast distance. Well, after all the waiting and anticipation, the James Webb Space Telescope finally gave us some unexpected answers. What did NASA discover? For years, scientists have been curious about Proxima B, and the James Webb Space Telescope finally gave us the chance to study it in incredible detail. When the telescope turned its powerful eye toward the planet, scientists weren't just looking for basic signs of life like water vapor, carbon dioxide, or methane. They were hoping to uncover clues about Proxima B's atmosphere, its surface conditions, and maybe even signs that it could support life. But what they actually found was something completely unexpected. On the dark side of Proxima B, there was a faint but steady glow. At first, this might seem like no big deal. Planets can have natural light phenomena, like volcanic activity or auroras, right? It could have been something like that. But as the team examined the glow more closely, they realized it wasn't behaving like anything natural. It wasn't flickering or fading in the way you would expect with natural events. Instead, it was consistent, steady, and didn't change much at all. The craziest part? It looked exactly like artificial light, like what you'd see coming from a city on Earth at night. Now, think about that for a moment. Artificial light on a planet that's 4.24 light-years away. If that doesn't make your heart race a little, I don't know what will. The implications of this discovery are huge. If that glow is indeed artificial, it could mean that Proxima B isn't just home to simple life forms like bacteria, but could actually be inhabited by an advanced civilization. Intelligent beings, capable of building complex structures and even altering their environment. The data from the James Webb Space Telescope has revealed the glow covers a large area of the planet's surface. We're not talking about a few scattered lights that could be explained by something like volcanoes or auroras. This looks like something much bigger, possibly an entire city, or maybe even multiple cities. Space is full of mysteries and unexpected phenomena, and just because something looks artificial, that doesn't necessarily mean it is. There could be natural processes happening on the planet that we don't fully understand yet. For instance, there might be some sort of geological or atmospheric event that produces a steady, consistent glow. That said, the possibility that what we're seeing could indeed be lights from an alien civilization is hard to ignore. This could be the closest we've ever come to finding real evidence that we're not alone in the universe. If it turns out that this glow is from an advanced society, it would completely change the way we think about life beyond Earth. It would suggest that intelligent life isn't some rare anomaly, and that our nearest cosmic neighbor could be far more interesting and complex than we ever imagined. Now, while we're on the topic of groundbreaking discoveries, there's another mystery that's been confusing scientists: Hubble tension. According to the telescope, the universe's expansion hasn't been consistent throughout its history. This mystery, known as the Hubble tension, has become a hot topic among astronomers. Back in 2019, the Hubble Space Telescope confirmed this issue wasn't just a fluke, it was real. Fast forward to 2023 and 2024, and the telescope, with its incredible precision, has doubled down on these findings. Using data gathered over its first 2 years, scientists have now cemented this odd discrepancy even further. The numbers aren't lying, and whatever is causing this inconsistency seems to be baked into the universe itself, not just a bug in our telescopes. To measure how fast the universe is expanding, something called the Hubble constant, astronomers rely on 2 gold standard methods. The first looks way back in time, almost to the beginning of the universe. It involves studying tiny ripples in the cosmic microwave background, the faint glow left over from the Big Bang, captured in exquisite detail by the European Space Agency's Planck satellite. From this ancient first light, scientists calculate a Hubble constant of about 67 kilometers per second per megaparsec, which means the universe is expanding at roughly 46,200 miles per hour for every million light-years of distance. The second method focuses on the more recent past and uses a clever trick involving pulsating stars called Cepheid variables. These stars are like cosmic lighthouses. As they slowly die, their outer layers pulse, getting brighter and dimmer in a predictable way. The rate of their pulsation tells us how bright they actually are, which can then be compared to how bright they look to us. By stringing these stars together, like rungs on a cosmic distance ladder, astronomers can measure distances across the universe. They combine this with data from Type Ia supernovae to calculate how much the light from these stars has been stretched by the universe's expansion, a phenomenon known as redshift. This method returns a Hubble constant of about 73 kme/s/mpc, significantly higher than the cosmic microwave background method. This gap between the 2 measurements has stubbornly refused to go away, even as scientists have tried to poke holes in the data or figure out where errors might be hiding. In fact, Rees and his team have only made the case stronger with their new JWST study. Using the telescope's unparalleled ability to measure distances with extreme precision, down to just a 2% margin of error compared to the Hubble Space Telescope's 8–9%, they've reaffirmed the higher value for the Hubble constant. Their results, cross-checked with other types of stars like carbon-rich stars and red giants, give a value of 72.6 km/s/mpc, nearly identical to earlier findings. It's like the universe itself is doubling down. This tension is here to stay. So, what could be causing this mismatch? Honestly, no one knows for sure. Some astronomers think there might be a missing piece in our understanding of the early universe. Maybe an unknown form of energy, like early dark energy, that gave the universe an unexpected boost shortly after the Big Bang. Others are tossing around ideas like exotic particles, weird properties of dark matter, changes in fundamental constants like the mass of electrons, or even primordial magnetic fields. Speaking of incredible discoveries, let's turn our attention to a familiar galaxy that's gotten a fresh new look from Webb. The Sombrero Galaxy. The James Webb Space Telescope has just given us a surprising new look at a familiar galactic neighbor, the Sombrero Galaxy. The galaxy has a distinctive shape that resembles a wide-brimmed Mexican hat, which is how it got its nickname. But Webb's latest image, captured with its mid-infrared instrument, gives us a totally different perspective. Instead of the glowing central core that stands out in visible light photos taken by the Hubble Space Telescope, Webb's infrared view shows off the galaxy's smooth inner disk, making it look more like a bullseye than a sombrero. In the background, you can see distant galaxies glimmering, adding even more depth to this cosmic portrait. The Sombrero Galaxy, officially known as Messier 104 or M104, is located about 30 million light-years away in the Virgo constellation. It was first spotted by the French astronomer Pierre Méchain back in 1781. He named it after his friend and fellow astronomer Charles Messier, who was famous for cataloguing star clusters and nebulae. Webb's advanced infrared instruments allow it to see through different wavelengths of light that are invisible to our eyes, revealing details we've never been able to see before. This capability gives astronomers a fresh perspective on old favorites like the Sombrero Galaxy. One of the most exciting things Webb's mid-infrared instrument picked up is the fine detail in the galaxy's outer ring. Dust plays a huge role in forming stars and planets, and Webb's image shows exactly how this dust is arranged. When the Spitzer Space Telescope, another NASA mission that's now retired, looked at the Sombrero Galaxy, the outer ring seemed smooth and uniform. But Webb's powerful instruments reveal a much more complex, clumpy structure. This clumpiness hints that there could be star-forming regions, almost like hidden stellar nurseries within the dusty ring. On top of that, Webb's observations detected carbon-containing molecules called polycyclic aromatic hydrocarbons in the dust ring. These molecules are usually found where new stars are being born. Still, even with these potential star-forming spots, the Sombrero Galaxy is pretty quiet when it comes to making new stars. Compared to galaxies like Messier 82, which churns out 10 times as many stars as the Milky Way, the Sombrero is practically taking a nap. The Milky Way itself produces around 2 solar masses worth of stars each year, while the Sombrero Galaxy is estimated to create less than 1 solar mass annually. For context, 1 solar mass is equivalent to the mass of our Sun, so the Sombrero Galaxy is definitely on the low production side. The supermassive black hole at the heart of the Sombrero Galaxy is also pretty laid back. While other galaxies have black holes that ravenously devour surrounding material and shoot out intense jets of radiation, the one in Messier 104 is far less dramatic. It does release a jet of radiation, but it's small and not nearly as active as the black holes in other galaxies. Even though the Sombrero Galaxy isn't the most dynamic place for star formation or black hole activity, it still has some fascinating features. For instance, it's packed with around 2,000 globular clusters. These clusters are like stellar retirement homes, each containing hundreds of thousands of old stars held together by gravity. They're perfect for astronomers who want to study groups of stars that are the same age but vary in mass and other properties. By comparing these stars, scientists can learn more about stellar evolution and the life cycles of different types of stars. Now, let's look into a theory that could flip everything we thought we knew about gravity and the cosmos. Alternate theory of gravity. Some of the discoveries this telescope has made could completely change what we know about gravity and the way galaxies form. Instead of the expected findings based on current models, Webb's data is hinting at a radical alternative theory of gravity, something that challenges everything we've been taught about dark matter. This has sparked debates and might force scientists to reconsider some long-held beliefs. For years, the leading model for understanding the universe has been the lambda-cold dark matter theory, or lambda-CDM. This theory assumes that dark matter, a mysterious, invisible substance, provides the extra gravity needed to form galaxies in the early universe. According to lambda-CDM, dark matter helped pull together small clumps of material over billions of years, gradually shaping the galaxies we see today. If this theory were spot on, ancient galaxies from the early universe should look small and dim because they would still be in the process of slowly coming together. But the telescope is showing us something entirely different. The galaxies Webb has observed appear big, bright, and fully formed, even when looking deep into the distant past. These findings don't match what the dark matter model predicts. Instead, they seem to support a controversial idea called modified Newtonian dynamics, or MOND, which was first proposed in 1983 by physicist Mordechai Milgram. MOND throws a curveball by suggesting that we don't need dark matter to explain how galaxies formed. Instead, it proposes tweaking Newton's laws of motion in regions where gravity is extremely weak, such as the outskirts of galaxies or the early universe. According to MOND, galaxies could have formed much more quickly than lambda-CDM predicts. In fact, MOND implies that these ancient galaxies didn't need dark matter at all. They just gathered together rapidly and got on with their business of star formation. Stacy McGaw, a professor of astronomy at Case Western Reserve University, has been a major advocate for MOND. He and his team have been analyzing the telescope's data, and what they're seeing lines up more closely with MOND than with the traditional dark matter theory. McGaw points out that if dark matter was really responsible for galaxy formation, things should have moved a lot more slowly. Instead, Webb's observations suggest galaxies came together in a flash, contradicting dark matter-based predictions. McGaw and his colleagues have been backing MOND for years, even though it's been a tough sell in the scientific community. Their 1998 paper argued that galaxies formed quickly without relying on dark matter, and now JWST might finally be giving them the evidence they need. McGaw even mentions that MOND-based predictions made by physicist R.H. Sanders match the JWST data better than predictions made by lambda-CDM advocates. Of course, MOND isn't without its challenges. One major hurdle is that it doesn't easily fit with Einstein's theory of general relativity, which is the backbone of modern physics. Finding a way to reconcile MOND with general relativity has been like solving a cosmic-level puzzle, and while the new data supports MOND, it doesn't completely disprove dark matter. Some observations still point to dark matter being real, so the debate isn't over yet. Despite the excitement, lambda-CDM still has a lot of support among scientists. This model has successfully explained many aspects of the universe, like its expansion rate and the distribution of galaxies. It's been holding strong for decades and has survived numerous tests. Plus, the universe's near-flat shape supports lambda-CDM, although there are some slight deviations that need further exploration. McGaw acknowledges that theories can be adjusted as new data comes in. Just because a model struggles to explain one set of observations doesn't mean it should be scrapped entirely. But he also believes that when a theory repeatedly misses the mark, it's a sign that something might be off. The JWST findings have given him and his team a sense of validation after years of pushing an idea that many dismissed. What do you think? Leave your thoughts in the comments below, and if you liked this video, don't forget to subscribe to our channel. See you in the next one.